All right, today we're going to talk about AI engineering. And I don't mean the high-level theoretical stuff. I mean the real, practical, get your hands dirty work of actually building and, well, controlling the powerful AI applications that are popping up everywhere. It's all about taming the beast. So let's dive in.
And you gotta love this image, right? It might feel like a meme, but it perfectly captures the entire challenge we're facing. On one side, you have this raw, powerful, almost chaotic intelligence that's created when a model learns on its own. And on the other side, that's the friendly, helpful, smiley face that we actually want to interact with. The whole field of AI engineering is about bridging that exact gap. It's about taming that beast and putting the smiley face on it.
So, if we're going to tame the beast, we really have to understand it first. Let's meet our main character, the foundation model. This thing is, well, it's incredibly powerful, but it can also be dangerously unpredictable.
At its heart, what a foundation model does is actually way simpler than you might think. You can just think of it as a completion machine. It's like a super-powered autocomplete. You give it some text, a prompt, and its one and only job is to predict the most probable next word. Then, based on that, the next word, and the next, and so on. They call this auto-regressive because it's constantly looking back at what it just wrote to predict what comes next. It's always asking itself, okay, based on everything so far, what word most likely comes next? A simple idea, really, but with absolutely massive implications.
And this right here, this is the central paradox of working with AI today. That whole probabilistic, what's the next word thing is exactly what makes these models so incredible for creative work. Brainstorming, writing a poem, you name it, it's amazing. But, and this is a huge but, that very same quality is a total nightmare when you need things to be factual, consistent, and reliable. This is exactly where hallucinations come from, and it's the main reason building dependable AI is so darn hard.
So that's the big question, right? If the model's inherently a little wild, how do we guide it toward useful and reliable answers? Well, that is where the engineer's toolkit comes in. These are the main ways we have to control the beast's behavior. We really have three main strategies in our belt, and each one has a clear trade-off between cost and effort. First up, you've got prompting. This is your first line of defense. It's cheap, it's easy, and it works great for simple tasks where the model already has the knowledge it needs. Next is RAG, which stands for Retrieval Augmented Generation. You pull this tool out when the model needs to consult specific, up-to-date, or private documents, like your company's internal knowledge base. And finally, there's fine-tuning. This is the heavy-duty option. You use this when you need to actually teach the model a whole new skill or a very specific style. Knowing which tool to use for which job is a huge part of being an AI engineer.
Let's break down RAG really quick, because it's such a clever process. It's basically a three-step dance. First, you ask a question, and the system retrieves relevant chunks of information from a knowledge base. Second, it augments your original prompt by just stuffing that information right into the context window. And finally, it asks the model to generate an answer using this new, much richer context. It's like giving the model an open book test instead of making it rely purely on its memory.
So if RAG is like an open book test, then fine-tuning, well, fine-tuning is like sending the model to grad school for a PhD in a very specific subject. You're not just giving it some notes for a single query. You are permanently changing the model's internal connections, its weights, by training it on a whole new, specialized dataset. Yeah, it's more expensive and complex, but it's how you give the model a fundamentally new skill.
Okay, so you've prompted, you've ragged, and you've fine-tuned your model. The beast is tamed, right? Well, how do you actually know? This brings us to one of the biggest, most frustrating challenges in the entire field, evaluation. How do you grade your AI?
And this really is the core of the problem. For some tasks, it's easy. Did it get the math problem right? That's a simple yes or no. But how do you objectively put a score on a summary it wrote, or a poem, or a marketing slogan? When the answers are open-ended like this, all our traditional ways of measuring performance just fall apart.
Now, this is where things get really interesting. What if we use another AI to do the grading? It sounds a little strange, but check this out. One study found that GPT-4's evaluations lined up with what human graders thought about 85% of the time. But here's the kicker. The human graders only agreed with each other 81% of the time. This means the AI was actually more consistent than the humans were. This is a huge finding because it points to a scalable way to solve this whole evaluation bottleneck.
But hold on, it's not a silver bullet. Let's look at the trade-offs. The pros are massive. It's incredibly scalable, it's fast, and it can even explain why it gave a certain rating. But the cons are very real, too. The AI judge is still probabilistic, so it can be inconsistent. It can have its own hidden biases from its training data. And of course, using a top-tier model like GPT-4 to grade everything can get very expensive very fast.
All of this leads to a really crucial point. You can't just tame the model itself. You have to control its entire environment. A production-grade AI application is not just a model, it's a fortress that you have to build around it. And this diagram shows what that looks like. A modern AI system is a whole workflow. A user makes a query, but then a planner module breaks that task down. It has access to tools like a web search or a calculator. Then an executor actually runs the plan. You see? The large language model is just one piece of a much larger, more intelligent machine.
So let's break down the walls of that fortress. A good AI system has layers. You've got guardrails, which act as security, filtering inputs and outputs for harmful content. You have a router, which is like a smart traffic cop, sending simple questions to cheap, fast models and saving the powerful, expensive models for the really hard stuff. You've got caches, which just remember the answers to common questions to save you time and money. And then you have agents, which give the model its superpowers by connecting it to those external tools.
And this is maybe the single most important takeaway here. You cannot prompt your way to a perfectly safe and reliable model. Safety and reliability are features of the entire system you build around the model.
Okay, so last big piece of the puzzle. Once your system is actually out there in the world, the job is not done. The final and maybe most critical step is closing the loop. You have to learn from how users are interacting with your AI to continuously make it better. And these are two absolutely brilliant examples of how to do this without annoying your users. Think about Midjourney. It knows you liked an image because you chose to upscale it. GitHub Copilot knows its code suggestion was good because you hit the tab key to accept it. This is called implicit feedback. It's baked right into the product design, and it is an absolute goldmine of valuable data.
But you guessed it, even this user feedback is not a perfect solution. You have to be aware of the biases that can creep into the data. There's leniency bias, where people just rate things positively to avoid the extra work of giving critical feedback. There's preference bias, where people might prefer a longer answer just because it looks more thorough, even if it's less accurate. And then there's sycophancy, where the model learns over time that the easiest way to get a good rating is to just agree with whatever the user says.
And that leaves us with a final, really challenging question that every AI engineer has to think about. As we keep closing that feedback loop, are we actually creating a tool that's more helpful and offers new perspectives? Or are we just building a sophisticated echo chamber that's getting better and better at telling us what we already want to hear? It's definitely something to think about.